Hi guys, I'm Gozier. Gozier. In this video, we'll be discussing chemistry, and I'll be showing you something about redox reaction. We'll be looking at the basics, introduction. Now, in this topic, we'll be talking about the definition of redox reaction, meaning of oxidation and reduction. Then we'll discuss derived meanings of oxidation and reduction. Can I rub off? So let's look at the definition of redox reaction, followed by this. I hope you've taken that down. Alright, I'll be rubbing off. Now, what is the meaning of redox reaction? Redox reaction are reactions in which oxidation and reduction occurred simultaneously. If in a reaction, oxidation occurred in that reaction, reduction also occurred in that reaction at the same time simultaneously, that reaction is a redox reaction. Now, what is the meaning of oxidation and what is the meaning of reduction? Alright, we'll go straight away to talk about that. Oxidation. Oxidation is an increase in oxidation number. I hope you understand what an oxidation number is. Primarily, oxidation number here is talking about the charge the species is carrying, whether an element or group of elements. I mean, whether an atom or group of atoms, the charge they are carrying, whether positive or negative charge or nothing, that is the oxidation number. Now, whenever this charge an element is carrying, the oxidation number increases. Principally, it is called oxidation, okay? I'll be showing you an example to illustrate this. Sodium in a reaction becomes sodium plus. What is the oxidation number of this sodium here? Like you can see, the oxidation number, it has no charge. That is what? 0. Now, its oxidation number here is, look at the charge it's carrying. The oxidation number is +1. Now, from 0 to +1, the oxidation number of sodium has increased from 0 to +1. This increase in oxidation number is called oxidation. Alright, we'll now look at the meaning of reduction. Okay? You may have paused the video earlier to take the notes down so that we could minimize our time even as we do another thing today. Okay, now what is the meaning of reduction? Reduction is the opposite of oxidation, and reduction is a decrease in oxidation number. Alright, I will be giving you an example to illustrate this decrease in oxidation number that we call reduction. Now look at it. Look at this. Chlorine gas becomes chloride minus in a reaction. The oxidation number of this chlorine here is 0. Like you can see, no charge here, as the oxidation number is 0. Here, its oxidation number is, 2 chlorine. I have 2 chlorine here, don't forget that. And its oxidation number here is -2. Don't forget that 2Cl minus is the same thing as Cl minus plus Cl minus. That's the meaning of 2Cl minus. And this -1 minus 1 is a total of -2. Okay, that is from mathematical standpoint. Alright. The oxidation number of chlorine here is 0. Here it has become -2. So its oxidation number has decreased from 0 to -2. This decrease in oxidation number is called reduction. So in the first case, you can now say sodium has undergone oxidation or is oxidized, and here you will say chlorine gas has been reduced or has undergone reduction. Alright, now these are the meaning of oxidation and reduction. We shall now be looking at the derived meanings of oxidation and reduction. Can I rub off? Now the derived meanings. Now we'll be looking at the derived meaning based on oxygen transfer. The meaning of oxidation and reduction based on oxygen transfer. Don't forget, we have established a general meaning of oxidation and reduction, and we've said that whenever oxidation number increases, it is oxidation. Whenever oxidation number decreases, it is reduction. Now we want to get to derive some definitions based on oxygen transfer and others. This is the first one we shall be looking at. Okay? I will be adding oxygen to an element, a sample element. And whatever happens to that element will happen to every other element. Now, if I add oxygen to that element and the oxidation number of that element increases, remember that increase in oxidation number of that element is called oxidation. I will now conclude or infer that increase in oxidation of the element, which is oxidation, is the addition of oxygen to that element. If I add oxygen to that element and its oxidation number reduces or decreases, then I will now infer or conclude that the reduction in oxidation number of an element, that is, reduction, is the addition of oxygen to an element. Okay, let us take a sample element and illustrate what we are talking about. Magnesium combines with oxygen to give you magnesium oxide. Now, I need you to understand that here there is addition of oxygen. There is addition of oxygen. Okay? Now, that is all I want you to understand about oxygen. We don't have any other to do with oxygen. Just to understand there is addition of what oxygen, because that is our defining standard, oxygen transfer. Now, I'm going to be analyzing this element, magnesium, and see what happens to it. The oxidation of magnesium here is 0. Magnesium here is +2 if you calculate it using the second arbitrary rule. If you don't know how to calculate oxidation of an element in a compound, you can shout me up on WhatsApp where you tell me that, and then I'll produce a video on that. Okay? The oxidation of magnesium here is 0, here is +2. From 0 to +2, the oxidation number of magnesium has increased. Don't forget, increase in oxidation number is called oxidation. But what is the cause of this oxidation or increase in oxidation number? Addition of what? Oxygen. I will now conclude that oxidation is the addition of oxygen to a species. Addition of oxygen to a species, that is oxidation. I have derived a definition for oxidation here based on oxygen transfer. Now, I'll be deriving another definition for reduction based on this same oxygen transfer. In that case, I will take the reverse of this our process to illustrate that. Alright, I'll be rubbing off. It's talking about based on oxygen transfer. This time around, I'll be reversing the process. In that case, I have magnesium oxide here. Now, here it has become magnesium by losing oxygen. Here you need to understand that there is a loss of oxygen. There is a loss of oxygen. What happens to our magnesium? For oxygen, we just want to know there is loss of oxygen. What happens to our magnesium? Magnesium here is +2, like you know. Magnesium here is 0. From +2 to 0, the oxidation number of magnesium has reduced, and we call that process reduction. That is a decrease in oxidation number or reduction in oxidation number. Now, what is the cause of this reduction? The loss of oxygen. Alright, I will now conclude that reduction is the loss of oxygen by a species. Let me clean it. I don't think this one is clear. The loss of oxygen by a species. Okay, that is the definition of oxidation and reduction. That is the definition of oxidation and reduction based on oxygen transfer. I have derived this definition based on oxygen transfer. Now I will be going on to electron transfer. Okay, can I rub off? Thank you. Now we're talking about electron transfer. Now this will be quite very similar. This will be quite very similar to the case of our oxygen transfer. Now, in the case of our oxygen transfer, I wrote a species magnesium and then I added oxygen to it. It gave us a species here, which is another compound. The same is what I'll be doing here. I will add electron to a species here, and that will be giving us something else. Now, in the other case of our oxygen transfer, I wrote a species and then I removed oxygen from it. So the oxygen will be alone here, and then the species becomes another thing here. In this case, the same thing is what I will do. I'll write the species here, and I will remove electron from it. And you see that electron will be standing alone, like oxygen in that case, and then the species will become something else here. Okay, let's go on. This is copper 2+. I am adding electron to it. This will become copper, just like the first case, but that one here was oxygen. Okay, now all I need you to understand is that there is a gain of electron here. Now let me analyze this man and see what happens to it. Here copper is 2+, here copper is 0. From +2 to 0, it has reduced. This is called reduction. I think I'm going to be having a meaning for reduction here. I will now infer, conclude that reduction is the, look at it here, gain of electron. I hope the writing is clear. By a species. By a species. that is reduction, is the gain of electron by a species. Now we'll go on to derive the meaning for oxidation. I've done for reduction. I'll derive for oxidation now. Okay? Pause the video probably and take down the notes. Alright? Now we'll be looking at the meaning for oxidation, but in that case let me illustrate the definition first. This is zinc, like in the case of magnesium and oxygen. Magnesium oxide became magnesium by giving out or losing oxygen. Here zinc will then become zinc 2 plus by losing or giving out electron. Okay, so you need to understand that here there is a loss of electron. I don't think this is clear. Let me make it clearer. There is a loss of electron. Okay, now I'm switching to a blank ink. Let me switch to a black ink direct. Okay, blue ink. Well, moving to. Okay, now there is a loss of electron here. Now let us see what happens to this species. This man is 0 here. This man here is +2. From 0 to +2, the oxidation number of zinc has increased from 0 to +2. Remember, we call that increase oxidation. We call that increase oxidation. What is the cause of this oxidation? Loss of what? Electron by this man. Okay? So we can now infer that oxidation is the loss of electron by a species. That is the meaning of oxidation. Okay, here we've been able to derive the meaning for oxidation based on electron transfer, and reduction also based on electron transfer. Now I'll be going to the meaning or derived meaning of oxidation and reduction based on hydrogen transfer. Can I rub off? Probably you pause the video and take down the notes. Okay? Alright. Now we're talking about based on hydrogen transfer. Hydrogen transfer. And I think that's the last one we're looking at today, since electropositive element and electronegative elements are the same thing as what we have done earlier. So I'm coming to that now. But let us discuss hydrogen transfer first. Okay? Now, this is an element. I am adding hydrogen to this element, chlorine. I added hydrogen to it. This will now become HCl, hydrogen chloride. Okay? The only thing I want to understand here is that there is addition of hydrogen. I hope this is clear. Okay? Alright, there's addition of hydrogen. Let us analyze this man now. We're adding hydrogen to. Let's analyze this man. Chlorine here is of no charge, 0, since it is standing alone according to the arbitrary rule. Now, chlorine here is -1. If you solve for it using the arbitrary rule or applying the arbitrary rule, and I'll talk about that in another video. Okay? Now, from 0 to -1, the oxidation number of chlorine has reduced, which we know, it is going down. The oxidation number of chlorine has reduced, and we know this process is called reduction. decrease in oxidation number, reduction. Don't forget that's the meaning of reduction. That's what we call reduction. Okay. Now, what is the cause of this reduction? Addition of what? Hydrogen. Now, I can now infer that reduction is the addition of hydrogen to a species. Okay, I hope you are following. All right. This is clear enough. Now, I'll be talking about the meaning of oxidation based on this hydrogen transfer. Maybe pause the video and take down the notes. Okay. Here, I'll be talking about the reverse of the process we just looked at now, in which case we have HCl. I will remove the hydrogen from it so that chlorine will be standing alone and hydrogen will be removed from it. Here, there is a loss of hydrogen or a removal of hydrogen. Alright, now what happens to chlorine in this reaction? Chlorine here is -1. So chlorine here is 0. From -1 to 0, the oxidation number of chlorine has increased, and we call that oxidation. So we can now conclude that oxidation here, or this increase in oxidation number, is what? Is the loss of hydrogen from a species. Loss of hydrogen from a species or by a species. The loss of hydrogen by a species. Okay? These are the meanings of oxidation and reduction we have derived from oxygen transfer, hydrogen transfer, and electron transfer. Don't forget, I will now give you a note. Probably pause the video and take this down. I will now be giving you a short note, a very short note. I hope you've understood the meaning of oxidation and reduction. By now, I know you must have understood what a redox reaction is, and also you must have understood the meaning of oxidation and reduction. And then, not only understanding their meaning, you must have understand their derived meanings based on oxygen transfer, hydrogen transfer, and electron transfer. Okay, now I'll give you a short note. Don't forget that electronegative element is an element having negative charge, e.g. oxygen is an electronegative element. Oxygen is an electronegative element. Now, on the other hand, an electropositive element is an element having positive charge. Having a positive charge. An example is e.g., just like the e.g. we have here. e.g. is oxygen. e.g. there is our Mr. Hydrogen Plus is having a positive charge, so it's an electropositive element. Therefore, the point I'm making here is that the definition hydrogen has for oxidation and reduction is the same definition electropositive element has, and the definition oxygen has for reduction and oxidation is the same definition that electronegative element have, because oxygen is an electronegative element and hydrogen is an electropositive element. So you can now say that oxidation is a gain of an electronegative element, and reduction is the loss of an electronegative element. On the other hand, you can come down to the electropositive element and say that according to hydrogen's own definition in hydrogen transfer, you will now say that oxidation is the loss of electropositive element and reduction is the gain of electronegative element. I hope you understand all this I've explained here. Alright, very good. Now, that is all about the introduction to redox reaction. In my next video, I'll be talking about the oxidizing agent and the reducing agent, the concept of oxidizing agent and the reducing agent, and how to find them in a reaction. Okay? In case you want to reach me for questions or problems, question on what I've done or problems, this is my WhatsApp number. Or probably you want to tell me videos to produce for you, you can also reach me WhatsApp number. Whatever reason you want to get me, you can reach me up with my WhatsApp number, and the number is 080 95 45 4046. That is my WhatsApp number. You can reach me up on WhatsApp via this number. Okay, thank you very much.